Today in this video we'll solve this question, which is median in a row wise sorted matrix. So according to this question, I have been given a matrix of size R into C, where R and C are always odd. I have to find the median of the matrix. I have been given this example, so let's see this example. Okay, R C. Okay, R is 3, C is 3. R is what? R is the number of rows and C is the number of columns. This is the matrix 1 3 5 2 6 9 and 3 6 9. So the brute force idea for solving this problem will be such that I will be using a vector, let's say ARR, and what I will do is that I will iterate the matrix and I will put each and every element into the array, just like this: 1 3 5 2 6 9 and 3 6 9. Yeah. Now the second task is to sort the array. I will do what? I will sort the array, right? You heard it correct. After sorting, it will be 1 2 3 3 1 2 3 3 5. Okay, 5 6 6 and 9 and 9. Correct. Now what I think it's very easy for now that 5 is the middle element. I can directly get it like this. I will pick R into C by 2 element. This element I am going to pick and I will return it. So what is the time complexity for this problem? Time complexity is such that this sorting will take O of n log n. Let's say what will be the n here? N is going to be R into C. Why I said R into C? Because R into C is the number of elements that are going to be in the array. Okay. So for sorting it took n log n, right? Yeah, and I will be iterating this matrix also, right? So that will be also O of n. And what is the space complexity? Space complexity is also O of n. Remember, here n is what? R into C. Yes. So as you can see, the time complexity and space complexity is quite high, and this is not the optimized approach for solving this problem. So let's try to see what is the optimized solution. Okay, let me erase this first. This is my array. Okay, now what is the optimized approach? I hope you read this line correctly. Given a row wise sorted matrix, row wise sorted matrix is such matrix, every row is sorted in this matrix. Here see 1 3 5, it is sorted. 2 6 9, it is also sorted. 3 6 9, it is also sorted. So my each and every matrix is sorted here. Okay, let's understand what is a median first. Let me plot this sorted form. Okay, 1 2 3 3 5 6 6 9 and 9. Correct. So so 5 is the median, say. Okay, so every value to the left of it will be lesser than or equals to, and every value to the right of it will be greater than or equal to. Yes. So this is what median is, right? So let's see what is our algorithm. I will be using simple binary search for solving this problem. Let's say start is this and is 30 for now. Well, in the actual code we will be keeping it 2000, but for now, for the sake of simplicity, let's take it just 30. Okay, start is this and this, and mid is this. Okay, 130. What will be the mid value? Mid will be 1 plus 30 divided by 2. It's 15. Correct. Now what I will try to do is that I will try to find numbers lesser than 15 in the matrix. numbers lesser than, I will try to find it out. Okay, so how many numbers are lesser than in the matrix? So in the first row I have 3 elements which are lesser than 15. In the second, 3, 3. So total 9 elements are there which are lesser than the 15. And for finding the number of number of lesser element than 15, I will use binary search for this also. I hope you know how to find the numbers lesser than this. It's a simple binary search, right? It's a binary search implementation. I hope you can code this. So you found that the numbers lesser than 15 is what? 15. You found it 15. Do you think that it can be the median? Try to think carefully. If every element every element in the matrix is lesser than such a particular element, that element how can be the median? How it can be median? A median is such element if the numbers lesser than that mid value is equals to r into c by 2, is equals to r into c by 2. Why I said that? Because I know that to the left of me numbers of element will be what? R into c by 2, and to the right also r into c by 2. Correct. So r into c by 2 is 4 for now, and this is also 4. Okay, so if 15 cannot be, so let's get back here. Okay, if 15 cannot be the value, do you think 20 can be my median? I don't think 20 cannot be my median. I'm sorry, I don't think 20 can be my median. Why? Because I know there will be still 9 elements which will be lesser than 20. Yes, 20 is greater than 15. How it can be? So what I will try to do is that I will try to move my search space to left. So what I will next time, and will become what? 14. Start will still remain same. Okay. So now what is the mid value now? Mid value is what? 14 plus 1 by 2. Right? It's 7. Now let's try to find numbers lesser than 7. So how many numbers are lesser than 7? Okay. Let's see. How many numbers are lesser than 7 in this row 0? 3. How many are here? 2 and 2. All together become 7. 7 numbers are lesser then 7 in the matrix. Okay, so 7 numbers are there in the matrix which are lesser than 7, not equals to, okay, 7. No, I am just counting the numbers lesser than 7 only. So do you think that 7 can be the answer? I don't think. Why? Because I know that if something is greater than this r into c by 2, if something count is greater than r into c by 2, how can it be the median? It is lying to the right part of the sorted matrix. It can never be the median, right? So what I will try to do is that I will try to move to my left part. So and will be decreased here, and will be what? Mid minus 1, it becomes 6, and start will be still same 1. Yeah. And what is the, now let's do for the next thing. Okay, so what will be the mid value now? 1 plus 6 divided by 2, it's 3. Now let's try to find how what is the numbers lesser than 3. Okay, in the 0th row how many numbers are lesser than 3? It's 1. How many numbers here? 1, and just 0 here. So there are 2 numbers which are lesser than 3. Do you think that it can be the median? Okay, let me give you a test case where it can be the median. Yes, you heard it correct, that it can be the median. Let's think of that case. Okay, let me write it 2 here, because this is what, how when it can be the median. Okay, let's see. I will simply use this. Okay, it's say 1 2 and say, let's say 3 3, and in place of 5 I have 3. Let's say I have 3, and in place of 6 also let's say 3. Okay, well, we can take it. Okay, 6 and 9 and 9. Okay, not 99, 9 comma 9. So what is the median here? What is the median? Definitely 3 is the median here, but it came out to be 2. I mean, the numbers lesser than 3 came out to be 2. This case might arise in the out question. Okay, so what I will try to do is that I will take an answer variable with me and I will say yes, 3 might be my answer. Just store it. And now what I will try to do is that I will increase the s value. I mean, I will try to move to the right part. Why? Because if this part had occurred in our test case, I have already noted the answer. Suppose this part didn't came up, and this is the test case. I mean, this is the test case, and what I did is that I found the numbers lesser than 3, and it came out to be 2, right? So but I know that this is not my I mean, this is not my median. I mean, it is lying to my left portion of the sorted array. I have to move to the right. It might happen that I mean, this is the test case and I will fall into 5, right? And 5 is the answer. It might happen. So let's see. But I have noted the answer already, okay? Because this case might arise there. Yes. So now I will go to the right portion. So I will say s equals to mid plus 1. 4 here and 6 here. 4 plus 6 divided by 2. It's 5. What is the mid? It's 5. Now what I said earlier was that I might fall into 5, right? I failed. Okay. So numbers lesser than 5, how many numbers are lesser than 5? It's 4. Numbers lesser than 5. So it's 4. Actually this is the actual I want. Okay. I know that this is the median. So I will do what? If I find that the count is lesser than what is the count? I mean, the count represents the numbers lesser than the given value, given mid. Okay, if the count is lesser than or equals to the r into c by 2, let's call this desired count. I mean, desired count dc. Okay, if this is the case, then I will say answer is equals to 3. I mean, answer is equals to mid. Okay, and I will try to move to the right part. I will try to move where? To the right part. S equals to mid plus 1. Right. If count is lesser than or equals to. Why I said didn't I mean, why I didn't use less, why I used lesser than or equals to. I hope you got this, and I know that why I didn't use greater than, because it's lying to the right part. And why I used lesser than because this condition might arise, and there you saw earlier that when I was finding the value number lesser than 3, I got 2, but 3 is the median here. So definitely I have to include this case also, so that I can note down my answer, right? Yes. So now, okay, let's jump here again. I found that now my answer is updated from 3 to 5. It was 3, now it's 5. Okay, start is equals to mid plus 1. It's 6 and it's 6. What is the mid? It's 6. Numbers lesser than 6. How many numbers are there which are lesser than 6? 1. I have 3 elements which are lesser than 6. 1 element here and 1 element here. So it's total 5. Each count lesser than or equals to desired count. What is our desired count? R into C by 2. What is R into C by 2? 3 into 3, 9. 9 divided by 2, what? 4. Desired count is what? 4. Is it so? No. So what I will do is that I will do and equals to mid minus 1. I mean, I have to go to the right. Why I am going to the I mean, sorry, not right, sorry. I have to go to the left, because I am trying I am currently at a number which is to the right of my sorted portion. Okay, so I will definitely try to move to left. So now I will try to move to the left. What will happen to the end? And equals to mid minus 1. What is mid? 6. Now it will be 5 and it will be 6. So at this condition the while loop will fail. Okay, I hope you got this. Now it's time to code. Okay, now let's move to the coding part. Okay, I have been given R, I have been given C, So the very first thing is I will do this, start equals to end, e is equals to 2000. Why I said 2000? Because the maximum value in the matrix can be 2000 here. Check it, it's 2000, yeah. And I will be using an answer variable. Let's say it's -1. While it's lesser than this, what is the mid? S plus e minus s by 2. I'm finding the mid. Okay, I will find int count, and this is get. I want to know how many numbers are lesser than the mid in the matrix. Okay, get numbers lesser than. Okay, I will pass simply the mid. I will pass, okay, I have to pass the matrix. I will pass the matrix, I will pass the mid, and then definitely R and C also. Yeah, if I find the count is lesser than or equals to the desired count. What is our desired count? Desired count is R into C by 2. Yes, let me declare a variable for this. I will say dc is equals to r into C by 2. Okay, let me put it into brackets, right, this way. If I find that the count is lesser than or equals to desired count, I will say it might be my answer, because this case might arise. If it is equals to the desired count, we are very happy. But if it is lesser than the desired count, then this case might have arisen. So I have to note, I have to note down the answer, like I have to note that mid. Okay, so I will say answer is equals to mid, and I will move to the right portion, because I have to move to the right portion. Why? Because I am currently present at my left portion of the sorted array. Okay, so if this condition fails, then I will say else equals to and is equals to mid -1. I was at the right position. Now I will have to move to the left. So I will simply return the answer. Now my task is to what? I have to code get numbers lesser than. Okay, so it will return int. So I will say int get numbers lesser than. So it's a vector matrix int mid int r, let's say. Okay, int c, correct. So how am I going to find this numbers lesser than? I will simply iterate over each row, and I will try to find in each row first what are the numbers lesser than, how many numbers are there lesser than the mid. I will try to find for each row, and I will add them up, and I will return it. So let's say int let's say count. Okay, so I will say for int I is equals to 0, I is lesser than r, I plus plus. So I will say count is equals to numbers lesser than. Okay, I have to pass what? I have to pass the matrix, I have to pass the mid, sorry, not int mid. I have to pass the mid, and I have to pass the I, because I need to know for which row I am calculating, right? And I have to, let's say, R and C also. Okay, at last I will return simply the count. Yes, now int numbers lesser than. Okay, so it will be vector of matrix int it's made an int row. I will say row number. Okay, and int r and c, int r and c, guys. Okay, int r and c. Now I will be using binary search for this. I will be using binary search. I don't think I need to explain this how I did this. Okay, I'll simply code it. So let's say int I have start is equals to 0 and int is equals to what? C minus 1, right? While start is lesser than or equals to let's say answer is equals to -1 first of all, and I will find the mid. Well, let's say it's let's say not mid here, it will be too confusing, right? It's a val again here, everything. Okay, val, right? What is the mid? A minus s by 2. If I find that my matrix of row, my mid, if I find that the number present at that is lesser than the value, then I will try to move to the right, because it might not be the first value which is lesser than the val, which is lesser than the val. Okay, so I will try to move to the, but it might be also the first value, right? I mean, sorry, not first, it might be the last value which is lesser than, and after that I might find every value greater than the val. So let's store the address, store the index where I found. Okay, answer is equals to what? Mid. So I will try to move to the right, as equals to mid plus 1, else if it is not the condition, I will say move to the left. Okay, right? And suppose I found that I don't want to explain this. Okay, well, it's a easy thing. I will return answer plus 1. I think I'm good to go. Sorry. Okay. Okay, so everything is saved. Thank God. Let me compile and run. There might be some errors. Fast. So slow, yaar, GFG. Even the tortoise will beat you, yaar. Might be my internet connection is slow. Yeah. Well, let's end the video here. I know that you got the logic, and it's not a big deal to code the logic. So, but still, I will paste the code into the comment section. From there you can have your code. Okay. Thank you for watching the video.